Hello friends, welcome back to the data structure tutorial, and today we will be discussing about insertion of a new node at the middle of a doubly linked list. In the previous videos we have discussed how to insert a new node at the beginning and at the end of the doubly linked list. So to create a new node we required few things, and those things are the structure of a node. So here I have already written the structure of a new node. So it is having a three fields: information and the two objects of node, that is next and previous, which will be storing the addresses of next and previous node. Then we will be creating one function which will receive one data, and we have to store this data in the node, and then that node should be inserted at a particular location. Okay, and then how to create a new node? So we have to create an object of this node class. So we have created an object whose name is temporary, and new keyword will allocate the memory is equals to the data members of that class, that is three data members are there. So it will create a three sections. So one of them is previous, one of them is information, and one of them is next. It will allocate some memory 500 suppose, and the name is temporary. So you copied the data. Let us assume that that data is 5. So you have inserted 5 in the information field on this line. Temporary's information is equals to data. Next and previous field you made as a null of temporary. So let capital N for the null. Okay. So you just created an independent node, and every time we have to check whether we have a existing list or not. And how to check it? So to check that, we will be writing one if statement. If start is equals to null. If start is equals to null, what it means? You will be giving the starting address as temporary's address. So what is the meaning of this? You just copied the address of temporary to the start. So there will be another pointer whose name will be start, and you copied 500 into it. So this will become your starting point if there is a no existing list available. What if there is a existing list available? Means else, we have to write else, and we have to check whether the existing list is available. So I'm taking some random data, and 2 suppose, and the addresses are like 700, it is 200, and it is suppose 500 is already there, so I'll be taking it as 800. Here 200, so this node will be pointing to this, and this will be 700, so it is pointing to the previous node. It is 800, so it will be pointing to this, and to this we have to write 200 here. And the last node will contain the next field as a null, and the previous field of the starting point will be considered as a null. So we have an existing list. Now according to our condition, we have to insert this node temporary at the middle of the list. So let's say we want to insert this node here somewhere, but we have to identify exactly, because there are two possibilities: you can insert here also and at the second location also. So we need to fix somewhere we want to insert that, right? So we have to take one more value from the user. Let's say user wants to store this new node whose value is 5 after 7. After which element you want to insert this node? So after 7 user wants to insert that node. So what changes you need to do? While accepting the value from the user 5, you need to accept one more value at which position you want to insert that new value. So here a single parameter will not work. You need to add one more parameter, and that parameter is integer position, after which element you want to insert. So let's say if user passing two values, so that value is suppose 7. So what it means, user wants to create a new node with the value 5, so we created it, and user want to insert this node after position 7. So after 7 you want to insert that new node. Okay, so we need to find out where is the 7 in the existing list, because we don't know where is the 7. You need to find where is the 7. Okay, so what I'll do, I'll write the existing list as it is. So suppose this is node, this is 8, this is 200, this is 700, this is again 700, this is 7, this is 800, this is 200, And what I'll make some small changes here. This is our new node which you want to insert, and this will be your existing node, that is 202 null and 800. So all these nodes are connected here. So this is connected to this node and this is connected to the previous node. Okay, so you want to insert this new node whose value is 5, next and previous field is null, address is 500, and the name of this is temporary. So you need to identify where is the 7. So what we'll do, we'll create another pointer p, we'll assign the value start to it. So what it means, 700 will be copied into p. And what you will check, you need to find out where is the 7, means where is this POS, and POS is compared with the value information field, because this field will be containing the value 7. So you need to check this value. So how will you write? You will be writing while p's info is not is equals to POS, till then move your p forward. Move your p forward. Let us understand this. So p equals to start, so p is at 700. Okay, p's info how much? It is 8. What is POS? It is 7. So 8 not equals to 7. Okay, go inside, copy p of next to p. So p of next is 200, copy it into the p, so it will go to the 200. Now again, what is current p's information? It is 7, right? 7 not equals to 7, false, it is equal. So what exactly we have done through this line? We have identified where is the 7. So p is representing that node. Okay. Now after this node you want to insert this temporary. Okay. So what will happen in the p's next field? In the p's next field you will be copied the address of temporary, and in the temporary's next field you want this 800, right? Because you want to insert this in between. So in the temporary's next field you want this 800, but we don't know where is the 800, right? So because it is not in the any variable, it is present in the p's next. So what we'll do, we'll copy in some variable. Let's say there is a variable called q, and after this loop I'll be copying p of next to q. P of next to q. Now what is p of next? It is 800, where you have copied q. So what is q? Q is 800. This is your q. Now it is very simple. What you need to do, in the p's next, in the p's next you will be writing 500. Okay, if you are writing 500 here, so automatically this will be pointing to the address 500. So where you have changed, p of next is your temporary. So after this here you will be writing p of next is equals to temporary. So the change we have made is this one. So p of next is temporary. Okay, and in the temporaries next we want the address of q. So here it should be 800. So now this node is connected. So in the temporaries next you want q. So these two lines are made. Okay, then you should not point to this node, right? And it should not be 200. In the queues previous you want temporary. So how much it is? It is 500. So it will be connected to this. Okay, so in the queues previous you will be writing your temp, right? Okay, so we have done that. And in the temporaries previous you want p, so it should be how much? 200. So temporaries previous will be pointing to the previous node. So temporaries previous is equals to your p, and then you have to close this else, and then you have to close this function. So these 4 lines will be representing your insertion of a new node at the middle of the list. So what are the steps? First you need to take 2 parameters from the user after which element you want to insert. Then you need to find out where is that node. So we identified here P is representing that node. After that node, you have to copy this existing next into some queue. So you copied the queue, then you, after insertion of this new node in between, you have to make the changes as per the diagram. So let us write a code for this. So in previous video we have written the code for insertion at the end. So quickly we'll create another function, that void insert at middle, and it will receive two parameters, one is your data and one is the position, after which position you want to insert. Then again you need to create a new node. So we have created the function for that, create node for the given data. Then you have to check whether the existing list is available or not. So the condition is start is equals to null, means we do not have any existing leads. So assign the address of temporary to the start. Else, if it is not the case, you will be finding the position where is that node. So you have to write p is equals to start. Here we have done that, p is equals to start, and then you have to loop over the information. So you will be writing while until p of info is not is equals to your position element, till then move your p forward. So p of next will be copied in p. So p will be representing that node, and once you find that, you have to copy the next node of p in q. Then in p's next you will be copying your new node, that is temporary, and in the temporaries next field you will be copied your q. So the link will be connected like this one, this and this, and then you will be copying q's previous as a temporary and temporary's previous as p. So q's previous is equals to temporary, that is your new node, and temporary's previous is equals to p, that is your identified node. Okay, now there is one condition which you have to consider while writing your logic. What if user has sent one value, suppose 99, which is not there in the list. So here you have to write the logic. So I'll just make the correction here. So while moving forward, what will happen? It will search whether p's info is 99. No, p will be here. Initially was at the starting point. Now p's information is 99. No, move p forward. Now p's information is not 99. So what will happen? P's next, that is p's next will be copied into the p. So what is will be the new value of p? It is null. It is null. Then there is no further movement, right? So we have to check here that if p is equals to null, in between somewhere p becomes null, it means that that position is not found, and we have to return back. So we'll be writing this in our logic. So here you have to check one condition. If while moving forward you moved so much that p becomes null, then we'll be printing one message to the user that POS not found, that element is not found, and will return back. Okay, this is the condition to check whether the given position is there in the list or not. Then will be returned from the that position. So this is the code for insertion of a node at the middle of doubly linked list. And in the next video we will be discussing about deletion of a node from all the three positions.